Assalamualaikum and good day all. In previous section, we have learned about finding Laplace transform, and later we learn about finding its inverse of a function. In this section, we are going to apply the informations gained to solve ordinary differential equation using Laplace transform method. Laplace is mostly used to solve engineering problems compared to method of undetermined coefficient and variation parameter or previous method that we have learned so far due to its capability to deal with many types of function. So we are going to use the term t instead of using x to represent the standard variable commonly used. Before we start to the example, let me explain general step to solve differential equation. So let's say we have a problem of first or second order differential equation. Using Laplace transform, we convert the equation into S term. So for example, I have yt. So when we want to find the Laplace transform, it will become capital Y S. And then, so we convert all the coefficient here by using Laplace transform. Then we rearrange until we get ys on the left side. So after we get ys on the left side and the other will be on the right side, then we find the inverse Laplace transform of, for example, let's say I put ys equal to yt. So on the right side, to find the inverse Laplace transform, we will use all the lesson that we have learned previously on how to find the inverse Laplace transform. So the right side will become our solution. Okay, to solve for the differential equation, we need to find the convenient expression for the Laplace transform of the derivative. Okay, for the first, second, and derivative. Okay, so it can be up to n derivative, but for our basic understanding, we only cover up to second derivative given initial and boundary condition. So the derivative, the Laplace transform of the derivative can be seen by the table here, right? So we have first and second derivative. Okay, so let's move to the example here. So in this example, we have first order differential equation where we have dy dt here. And we also have the initial condition y0 equal to 3. So what does it mean here? So this is yt equal to 3. So it means that t equal to 0, we have y equal to 3. Okay, so let's first find the Laplace transform. So I just write down here Laplace transform of y prime minus 6y equal to Laplace transform of 4e negative 2t. Okay, so Laplace transform of y prime. So we refer to the table, it will become s capital Y. S. Okay, be careful with the capital or small y minus y0. So this is the value of Laplace of y prime. Okay, Laplace of y prime. So when we have capital Y, it indicates that the value inside here must be S. Okay, small y indicate that it must be in t term. Right, so I just continue. So we have minus 6y. The Laplace here is equal to minus 6. Laplace of y is equal to ys. Okay, I didn't write down Laplace term anymore. Okay, because we have already find the Laplace transform. And we have on the right side Laplace transform of 4 exponent negative 2t. So our a is equal to negative 2. 4 bring out, we have 4 multiplied by 1 over. So 1 over s minus a. So s minus minus 2 we get plus 2. Right? So we have y0 here. So y0 is given in the question here. Example here we have y0 equal to 3. So we can substitute with the 3. Okay. So after we substitute, what else we can do? We can factorize. Okay. So our aim is to make sure that only ys remain on the left side. We only want ys. Okay. So first we can try to factorize. So let's say if I factorize, I bring first. So s y s minus 6ys equal to 4 over s plus 2. So minus 3 here, I will bring to the right side. So we have plus 3. Okay, then we factorize on the left side. So ys, we will have s minus 6. Okay, so that when we factorize, we can bring this one to the right side. So before we bring to the right side, okay, so equate the denominator first. So we have s plus 2. So 4 plus 3. This one over 1. So we need to multiply by s plus 2 also. Okay, up and down. So we will get 4 plus 3s. Okay, make sure you multiply both. Plus 6 over s plus 2. Simplify, we will get 3s plus 10 over s plus 2. Alright, so then we remain ys on the left side. Bring s minus 6 to the right side. We will get 3s plus 10 over s minus 6 s plus 2. After we have rearranged ys on the left side, we find the inverse Laplace transform on both sides. So I just write down inverse Laplace of ys equal to inverse Laplace of 3s plus 10 over s minus 6 s plus 2. Right? Okay, I bring this one to the other page. So we want to find the inverse Laplace of ys. It is yt. Okay, for the right side, we have 3s plus 10 over s minus 6 s plus 2. So how to find the inverse Laplace transform here? So we can solve this one by using partial fraction. Okay, so let's do the partial fraction. So I just copy this one first. So we have 3s plus 10 over s minus 6 s plus 2 equal to a over s minus 6 plus b over s plus 2. Right, so we equate the denominator here. We will have s minus 6 s plus 2. So here at a must be multiplied by the other. We have s plus 2. Okay, while for b we multiply by the other side, we have s minus 6. Okay, so since we have the same denominator, we can just take the numerator here. We have 3s plus 10 equal to a s plus 2 plus b s minus 6. Okay, so let's say we choose any value of s equal to negative 2. So we will get 3 negative 2 plus 10 equal to a. Negative 2 plus 2 we get 0 plus b. So negative 2 minus 6. Alright, so it's 0 0. Then we get negative 8b equal to 10 minus 6, we get 4. So our b is equal to negative 4 over 8, which means negative 1 over 2. Right? Okay, so finish for the first assumption. Then we do another assumption. Let s equal to 6. So we have 3, 6 plus 10 equal to a 6 plus 2 plus b 6 minus 6, we get 0. Okay, then we get 8a. Okay, 10 plus 6 multiplied by 3, 18 plus 10, we get 28. So a equal to 28 over 8, we get 7 over 2, right? So after we get the a and b, we just substitute back. Okay, so I just copy. So you want to find inverse Laplace transform of ys. Just now we have already yt. Okay, and we want to find inverse Laplace of the partial fraction. So a over s minus 6. So a is equal to 7 over 2. Okay, 7 over 2 over s minus 6 plus b. b is minus 1 over 4. So minus 1 over 2, sorry. Okay, then we have s plus 2. Okay, so our right side is already in the partial fraction. Okay, so we are going to use this term instead of using the complex form. Okay, so to find the inverse Laplace for this one, equal to 7 over 2 inverse Laplace of 1 over s minus 6 minus 1 over 2 inverse Laplace of 1 over s plus 2. So we will get 7 over 2 inverse Laplace of 1 over s minus 6. So a equal to 6. We have exponent 6t. Okay, minus 1 over 2. So a here equal to negative 2. So we have exponent negative 2t. Okay, so this will become our yt. Okay, I make it clearer. So we have yt. Okay, that's all I think for this topic, and I hope you understand very well for this topic. So all the best.